So today we're going to talk about sequences. In mathematics, a sequence is an enumerated collection of objects in which repetitions are allowed. So, for example, we have the sequence that we all know: 1, 2, 3, 4. So in this sequence, each term increases by 1. So the sequence or the formula to this example will be n plus 1. So we have two types of sequences. This is the first one, and it's the diverge sequence. This simply states that if a sequence does not approach a certain value, then therefore we can infer that the sequence must diverge. Example, let's use the previous one, n plus 1. So as the values in this sequence increases, so 1 plus 1 is 2, 2 plus 1 is 3, the sequence will grow infinitely large. So it does not approach a certain value. So we can infer that this sequence must diverge.
Okay, the second type of sequences is the converge property. In this property, the sequence is approaching a certain number or value. For example, in this sequence, 1, 0.1, 0.01, 0.001, 0.0001, you can see that the number 1 is decreasing and it's approaching 0 because it's getting smaller and smaller, so this sequence converges.
Okay, so now we're gonna see some examples of some type of sequences, if they diverge or converge. So the first sequence, an, is the following: n plus 1 over n times n minus 10. Okay, so we need to first simplify this expression, since we cannot infer if as n increases, if this reaches a certain value, or it does not. So I'm gonna simplify it. N2 plus 9n plus 8 over n2 minus 10. So we can see this as a limit. So as n approaches in infinity, what happens? So we can see, since the greatest exponent in both the numerator and denominator, it's 2, both cancel, and we can say that this sequence approaches 1. So since it approaches one certain value, we can say that this sequence converges. Yeah? So the next sequence is Bn, and it's e to the n power plus 1 over e times n plus 1. So as we can see here, as n goes to infinity, we can say that this grows faster than the denominator. So therefore, this one approaches infinity. So since it does not approach a certain value, this sequence diverges. third example is the following: n squared plus 1 over n times 1000. So we can see that as n approaches infinity, the denominator, as this example, grows faster than this one since it is squared. So we can say that this sequence approaches infinity, therefore it diverges. The last example is the most tricky one. In the end, it's negative 1 to the n. So as you can see, like let's say like we raise the n to the 1, it's to the 1, negative 1 to the 2, it's 2, positive 2, positive 1, sorry, negative 1 to the third, to the 3 is negative 1. So it also oscillates between negative 1 and positive 1. So even though it does not like goes to infinity, it also does not approach a certain value. Just the number oscillates between 1 and negative 1. So therefore we can infer that this sequence diverges since it does not approach a certain value.